everyone, I am Anupma. I welcome you all at yet another Ashnix Google Hangout session. So let me start with the introduction first. Ashnik is a leading solution offering company and we bring about business transformation, agility, and innovation by offering solutions around big data, analytics, and Oracle database replacement needs. In our countdown to v9.5 series of Hangouts, we will be covering some great features of Postgres v9.5 and its real-life capabilities. So let's welcome Sameer, who is our senior database architect, who will be talking more about this. So Sameer, welcome to you.
Hello everyone. Sorry, it took me a while to unmute myself. Hello everyone. Like Anupama said, we are starting our series of few hangouts in which we would be covering few interesting topics about features of 9.5 PostgreSQL version. Meanwhile, if you are interested in checking out our previous hangouts, which covered various topics ranging from performance tuning, SQL tuning, and replication setup, setting up a scalable cluster, or partitioning. Please do that. You can visit our YouTube page, our YouTube channel of Ashnik, which is Ashnik Biz, and you can check out our past videos and learn from them. If you have any queries, you can post comments or write to us. Now let's get started with this hangout, this topic. So 9.5 Alpha 2 has been released quite recently, and there are a lot of great features which are there in version 9.5. And we are excited about a lot of these features. Some of these are foreign table inheritance, which we are going to cover in today's hangout. Importing a foreign schema, which basically makes it easier for a user to import the complete schema rather than importing individual tables in a foreign data wrapper. Basically, it will work for Postgres foreign data wrapper. Brin indexes, which is block range indexes, which is going to improve the performance for large tables by quite a good magnitude. When I say improve the performance, I mean index scan performance. There is a new gist index only scans introduced. There are OLAP features introduced as part of grouping set, cube, and roll up. One of the most sought after features called upsert has been introduced, which is to insert data, or if the data already exists, update it. That has been now added natively in version 9.5, and you will be able to make use of that. A workaround was possible in previous features, but the new syntax is much more intuitive and avoids few race condition issues compared to the previous workaround. There are new operators and functions which are getting added for JSON-B as well. So your NoSQL feature set in PostgreSQL is getting more enhanced with version 9.5. Now let's look at the feature that we are going to discuss in today's session. Let us start with basics, and let's take a look at what is table inheritance. Basically, in PostgreSQL, you can make a table to inherit from another table, and when you do that, the child table would inherit all the attributes and data types of the parent table. These inherited tables can have check constraint, and the child tables which are being inherited from the parent table can be used to set up partitioning. We covered this in great detail as part of our previous hangout, which was on partitioning. You can go and explore our YouTube channel to further learn how partitioning can be set up using these child tables and table inheritance. We would be sharing this PPT over on our slide share, so you can get a link to that particular Hangout using the link which you see on the screen. What are foreign tables? Let's take a look at what are foreign tables. So basically, in PostgreSQL, you can have foreign data wrappers. These foreign data wrappers are actually based on SQL med interface or SQL med specifications, which is a way to access other databases from PostgreSQL. These other databases could be a PostgreSQL database, it could be file system, or it could be a NoSQL database like MongoDB, Elasticsearch. It could be Twitter. There is a foreign data wrapper which is available for Twitter. Quite interesting. And there are a lot of other foreign data wrappers as well, which are quite interesting. Like there is one for pgdump. Now, depending on the implementation of this foreign data wrapper, you can actually use them to read and write into foreign tables. Basically, once you create a foreign data wrapper, you need to create foreign tables. These foreign tables are nothing but a table existing in a remote server. So you would register these servers, and then you would register a link to these foreign tables as well. We did a hangout on MongoDB foreign data wrapper in past. Feel free to go out and explore that and learn how a foreign data wrapper can be compiled and how it can be used. This will also give you a feel of how you can use other foreign data wrappers. There is a good documentation available online for using Postgres foreign data wrapper and file system for foreign data wrapper. So we are not going to get into much details of how to use them in this Hangout. Rather, we will see how these two features, foreign data wrappers and table inheritance, is going to be combined in version 9.5 and how it can be used to achieve basic sharding. So in 9.5, these foreign tables can participate in an inheritance tree, which means a local table on your Postgres database can inherit from a foreign table, or a local table can become a parent and it can be inherited towards a foreign table, which means your child tables could be existing on different databases, and you can import these child table as a foreign table which is inherited by a parent table. Now, this might look a little confusing at the moment, but you will get a hang of this once we get into the syntax. Another enhancement which has come in version 9.5 is that you can add constraints on these foreign tables. Now, these constraints might not be as useful for enforcing the data integrity, but they are quite useful when it comes to query optimization and specifically partition pruning, because these constraints can help optimizer identify which of the child tables are not to be scanned for a particular data set, which is also something which optimizer does while doing partition pruning. When you have partitioned a table, you can get more details again from our hangout which we where we covered partitioning in detail. Now, one other thing which could be done is you can use hybrid systems for posting different partition sets. So some of your data could be on the file system and some other data could be on a Postgres database. And you can also have mix and match, which means that some of your child table could be local and some of your child tables could be on a Postgres database, and some other child tables could be a file system file, a comma separated file basically. And if these if your foreign data wrapper allows you to do write operations, you can also do write from a central Postgres server, which will get routed to different child tables, and these child tables will be on different servers, which means you are able to achieve basic sharding feature. Now, let us quickly start with a quick quick demo of how we can set up this distributed database in PostgreSQL. The first step would be to set up a foreign server, which means I will be creating a foreign data wrapper, and then once that is done, I will be creating foreign servers. Once that is done, I'll create a main table, a table which is on my main Postgres server, and I will be creating other remote tables in remote servers. Then I will be importing these remote tables as foreign tables, and then I would be creating some check constraints on these tables. I'll have to create a trigger to enable my table, my main table, to distribute data among different child tables. Now this is pretty much similar to partitioning, that you would notice that when you go through our Hangout on partitioning, or if you are already aware of basic partitioning and how it works in Postgres, you will realize that this method is pretty similar to doing partitioning on a local database. Only difference is the partitions are going to be on different servers. So this is a demo environment that I have prepared. I have a server running on IP address 192.168.37.149. So let me connect to that server. Let me show you a quick demo. Let me change the appearance a little bit so that it is legible to everyone watching this video. Let me make some color changes so that yeah. So let me log in as Postgres database. Let me shorten my prompt with shell prompt, and now you see I have got a database on 192.168.37.149, and let me close my Dropbox as well. All right, and I have got a database called Postgres. This is the database where I have my main table. Select star from employees. This is a database where I have my main table called employees. Now I have got another system which is DB1. So on this very same server, I'm hosting another database called DB1, where I have got, oh sorry, not DB1, but it is v9.5 sh1. And over here again I have got a table called employees. This is just a portion of that data. It doesn't contain all the data that I have got. As you can see from both the outputs. And there is one more There's one more instance running here, which is on a different port, 5431. So this is a different server, and this server could be running on another IP address. It could be running on a different machine as well. It is just that for this demo, I have created both my Postgres servers on the same virtual machine, but they could be on two different servers as well. And in fact, there could be two different kind of systems. And here again, I have got table employees, and now this was a brief about the demo environment. My master database is running on 5432 port, and the database name is Postgres. I have got another server running on 5431, which is my second shard, and my first shard is co-hosted on the same master server, but on a different database, which is v9.5 sh1. Now, the first step is to connect to the master database and create an extension. So you see here, there is a create extension command that I need to fire. And this create extension would create a foreign data wrapper extension called Postgres FDW. Once this extension has been created, I can add servers of type Postgres. So here in my second step, I'm creating a server with Postgres FDW, as you can see here, and I have to specify various options for the host, database name, and port. Basically, all the details to connect to the server. Once the server has been added, I need to create a user mapping for this server, and this user mapping will be using a username called Hangout demo. This is a user who will be used to connect to my shard, or who will be used to connect to this foreign server. Similarly, I'm adding second server as well, and I'm using a mapping for this server as well. Now, once this is done, now I can import tables from these servers. And that is what I'm doing here. I'm creating a table. I'm creating a table employees, which is my main table. And then I'm creating a table employees, which is inheriting my main table, which is going to be inherited by the main table. So as the first step, I'm just creating all the tables in my master database and all the shards. Once that is done, I'm going to create a foreign table over here, and this foreign table has a check constraint. As you can see, I've got a check constraint on my foreign table, and it inherits the main table, which is on server 1. If you remember, in the very first step, I gave a name to my server. I gave a name to my server, server 1, and the second shard was given a name, server 2. And this is trying to inherit a table called employees. Let me just correct this syntax. There is a slight issue here. So I'm going to use this. All right, so sorry, there was a typo earlier because of copy paste mistake. Because I was trying to follow a tutorial earlier for my own learning, and somehow that got cascaded in here as well. So just for a reference, this is the same example that I have used during our partitioning hangout. So you will be easily able to correlate this example with how partitioning works. So yeah. All right, so over here you can see that this is a list based partitioning that I'm trying to achieve. And here there are two partitions, emp1 and emp2, and they both refer to a foreign table. Now these check constraints will not be enforced on the native databases. So I can still go to server 1 and insert some data which violates this check constraint. And these check constraints need not exist on the remote tables. As you can see on my screen, if I try to explain the database, there is no check constraint defined here on the job. There is no check constraint. Whereas when I connect to my master database, I have got a check constraint defined over here. So basically, while creating this foreign table, I'm trying to specify the inherit clause, which means that which table does it inherit, and I'm specifying the server details. Basically, this is the name of the foreign server or the remote server to which you would be connecting. And this is the table option. This is basically the name of the table which it needs to import. So employees is a table which is existing on server 1. Now, if I drop employees from server 1, I will not be able to get any data from emp1. So this name need not be same as the master table. This could be any name, but it has to be same as the table in the native database. Now similarly, I'm creating second child table as well, which also inherits the same master table and refers to second server for the same table name. Now I'm creating a trigger function whose purpose is to insert data in respective foreign tables. So if I get a new entry where job is in manager or president, I have to pass it on to emp1. And if this data is coming for salesman or clerk, I need to pass it on to emp2. Once I have created the trigger function, I need to attach the trigger function to a trigger which is defined on employees. All this I'm doing in my master database. The definition of trigger function and the definition of trigger, this has to be done in the master database. Once that is done, if I try to insert new data in employees on master DB, that will be routed to respective tables or respective shards rather. So as you can see over here, if I select star from employees, I get all the data. If I select star from emp1, I get only 2 rows, and emp2 again gives me 2 rows. One of the caveats that you will notice here is the primary key can be duplicated because this data exists on 2 different servers and 2 different partitions. So Sultan and Saroj are 2 different employees with same EMP number. This has happened because both rows were routed to 2 different partitions and they have 2 different primary keys. To overcome this, you can actually have auto incrementing EMP number and you can create alternating numbers. So what I can do is I can define 2 sequences, sequence 1 and sequence 2, and I can attach each of them with individual partitions. In that way, I don't have to insert the data manually for EMP number, and at the same time, EMP number will be auto incrementing for each new employee which is hired. And the third advantage, as I said, would be to overcome the caveat or mitigate the issue which you see here about duplication. Now, when I try to select data from employees with a filter that will try to scan only a specific shard or only a specific foreign table. Like in this case, it is trying to cascade that to the EMP2, and this is happening because EMP2 has got a EMP2, as you can see here, has got a check constraint. This won't happen if I drop this check constraint. If I drop this check constraint, there is no way optimizer can figure out where should the data be fetched from. So let us try to do that. Oh, sorry, I'm going to work with EMP2. And similarly, let me try to fire the select query. Now when I fire this select query, it is still going to EMP2. The reason is this is this is uh, this is done as part of partition pruning, in which Postgres optimizer tries to remove those partitions which are not applicable. So because of the check constraint on EMP1, it is able to decide that the data salesman does not exist in EMP1. So it is rather an exclusion technique that optimizer uses. That is why I'm still seeing EMP2 scan here. Now if I try to do a scan for, let's say, president, sorry, typo, you can see that both EMP1 and EMP2 is being scanned. So Postgres is not able to determine whether EMP2 should be excluded or not, because there is no check constraint on the EMP2. So this definition of check constraint is very important if you want to do partition pruning or shard pruning, to be more precise, or to use a term which would be probably more applicable in version 9.5. Apart from that, you must make sure that ex, uh, constraint exclusion has been set. If I set it off, you can see that still both partitions would be scanned. So if you want to enable this partition pruning, you must make sure that you have proper check constraints defined on all these servers, or rather all these foreign tables, and you have constraint exclusion set to off on the master database. Now let's come to use cases. One of the most obvious use case is that you can create distributed databases. You can have geographically distributed databases which are across various regions in your country, and local servers could be adding data for specific regions locally, and you can have a centralized database which can which can inherit all these foreign tables, and it can give you a unified view of all regions. You can also do a bulk upload in individual remote databases as and then add them as a partition. You can also have, like I said in the beginning, you can also have one parent table and two different child tables which are on different kind of systems. You can also use a file for example, one of the things that you can do is, you're getting a lot of data from a file system, or you're getting a lot of data in form of flat files which is in CSV format, and you need to upload this into your database and allow your users to query this data. Now this upload might take a lot of time, So while you are doing this upload, you can add this file as a partition, the file itself as a partition. So this file itself could become a foreign table, and that foreign table could inherit your main table that is in your production database. Your users can query this main table and they will be able to fetch data which is coming from the file. And then once the upload is completed, all you need to do is detach the partition which is referring to the CSV file and attach this new table. So your users don't have to wait for all the data to be uploaded. Now, while this access could be slow, still the data in the flat file is immediately available to them. Then again, another thing that you can do is, for example, you're monitoring log files and you want to monitor the latest log file as well. So you can add each log file as a partition, or you can import the data in historical log files or the older log files in a table, and new log files which is currently being used by the system can be added as a partition. So you can get log information from old files which is already in the database, as well as from the recent or the current file which is still being written into. You can also use it with other popular foreign data wrappers like MongoDB, Elasticsearch, Hadoop, or pgdump. So if you like this topic, if you want to, if you like our Hangouts, please drop us a note about it. It certainly feels good to know that people are liking what we are doing. Apart from that, if you have any feedback for us, something that we can improve in our Hangouts, or if you have any suggestions for any new topics, please write to us. We would be happy to include a hangout or a topic on a specific topic, a topic in our future Hangouts. Apart from that, if you have any questions regarding the current session or this session, please drop us a note at success@ashnik.com, or you can leave your questions in the YouTube video comments. Now let me go back to the Hangout and see if we have got any questions here. Apart from that, if you have any questions regarding, sorry for the echo, I clicked on a wrong link which opened up the Hangout session itself. Yeah, so let me see if there are any questions. Yeah, so someone has asked what could be the other use cases of using hybrid system apart from file system, or to rephrase the question, or to explain it to everyone. Sandeep wants to know that whether there is any other use case where a hybrid cluster or a hybrid partition is applicable, or a hybrid sharding is applicable apart from file system. So on top of my head, one of those which I can think about is there is an interesting Fornita wrapper which allows you to read from pgdump, a pgdump. So you can take a pgdump out of your database, and that pgdump can be read using a foreign data wrapper. Now this can be quite useful for people who design archiving systems. You can archive your older data in pgdump, and then you can use a foreign data wrapper to read from this historical data. So your recent data stays in your live database, whereas your older data sets goes into different dumps in different pgdump outputs, and those are acting as a partition for your main table, and you can query them whenever you want. So it makes your life quite easier when it comes to querying from the historical data. The queries might run a little slower, but you don't have to restore that data. to query that data. And all of that data is given in a single unified table to you. I mean, if you have any specific reason to use this, or you are trying to see how you can benefit from it, drop us a note and we would be helpful. We would try to be as helpful as we can, and we can see how we can help you further on specific requirements that you may have in your environment, or we can help you explore how you can use this technology in your environment. Yes, there is another question here. Yes, in our further hangouts, we plan to cover more 9.5 features and see how they can be useful for end user and what is their real time applicability or their real time usage. So yes, stay tuned. In next couple of months, we are definitely going to do more hangouts, which will be covering more specific 9.5 features. If you want us to explore or talk about a specific 9.5 feature and discuss more on how it can be helpful to you, we'll be happy to include that feature. Well, I guess that is all at the moment. And if you have any further questions, leave it in the YouTube video comments. This just to revise it back, all these hangouts that we do, they become a YouTube video. It takes like a couple of minutes for them to get uploaded on our YouTube channel, and you can go and refer to them. All the slides that we use, you can download them from our SlideShare channel, and all these examples that we are covering here are available on these slides, so you can copy paste these examples and use them and explore yourself and tweak them to suit your need or experiment with them.